Hello, dear listeners. In this video, we will explore the main stages of laser alignment using the Vibration Analyzer ADL MS52PRO with alignment function. First, let's talk about the equipment used for this alignment. In this case, it is a stand that simulates a stationary and a movable machine with corresponding adjustment bolts. Additionally, on this stand, a shaft with a half coupling is installed. Sensors S for the stationary machine and M for the movable machine are mounted on the shafts through special supports and chains. When the device is turned on, we see the main menu. Next, we enter the alignment mode. We enter it and select the desired alignment, namely the horizontal one. We select a new task. In this device menu, we can already observe the arrangement of both the stationary and movable machines. We need to input all the necessary data, which includes a distance of 350 mm between sensors. The distance from the sensor to the coupling is 175 mm. Also, note the distance from the sensor to the first support, as well as the direct spacing between the first bolt and the second bolt. After entering this data, we can also access additional settings where we can set the required precision for achieving alignment. In this case, we have set the precision to 0.5. We confirm this precision and can proceed directly to the alignment procedure menu. In the first stage, sensor S and sensor M should recognize each other. They need to identify the angles at which they are positioned. In this case, it is 180.8 degrees for sensor S and 182.8 degrees for sensor M. From this position, we can proceed with the alignment process. Alignment can be of various types. In this device, there is a 3-point mode, corresponding to 9, 12, and 3 o'clock. This means that in practice, we only need to capture 3 points. If there are 4 points, it is a complete revolution of 360 degrees. There is also a multi-mode, where it's possible to capture the minimum number of points and perform the calculation. The more points we capture across the entire rotation, which is 360 degrees, the more accurate the alignment will be. Let's start taking the readings. We took readings in the vertical position, and the device prompts to continue. Next, we rotate the sensors in one direction, securing them to prevent further rotation. Pressing start, we obtain the readings. Then, by turning the sensors towards ourselves, we capture another point in a different position. We press start, and the next set of readings is recorded. 3 points were measured. Pressing the F5 button, we can perform a preliminary calculation and even leave these sensors in such a position. The device suggests adjusting the movable machine either in the horizontal or vertical position. Let's leave it in the horizontal position. We press start. The device warns us not to rotate the shaft during alignment, and we observe the misalignment we have in the equipment horizontally. There are 2 types of misalignment. The first one is parallel. The values are displayed at the top, and we can see that the instrument is satisfied with these values. The second one is angular misalignment. On the device, we observe that the values are not suitable. Next, we pay attention to the upper values. Using adjustment bolts, I need to move the equipment towards myself. as indicated by the arrows on the device at 2.3 and 2.93. We observe how the first value has changed, and we see the alignment value that we have achieved. It is important to note that alignment needs to be performed in multiple positions of the sensor. Therefore, we switch to the vertical mode and confirm. The device is not ready because the sensors are not in the vertical position. We move the sensors to the vertical position. The device confirms that it is ready. We press the Start button. And now we proceed directly to vertical alignment. We observe that the equipment on the supports needs to be lowered by a small amount. We adjust the position vertically. On the device, we see that the values are changing. In this case, it is still not sufficient, so we continue. By adjusting the position of the movable machine in the vertical orientation, we achieved the alignment reading. Now we can further check in the horizontal position by switching the mode. And we see that the values are acceptable. Now let's examine the structure of the stand and the sensor mounting. I will remove one sensor. The sensor is attached to these stands, and on the shaft, it is secured using chains. The sensor itself is screwed onto the stem. This stem can be extended depending on the diameter of the shaft on which we will perform the alignment. Thank you for your attention.